All right, so we're going to start in with some example proofs. Again, this is still kind of from section 2.5, and these proofs are going to be algebraic proofs. We do need to start with some kind of geometric relationship. That's usually the part that people struggle with the most. But after that, it gets pretty simple and straightforward. So for this first proof, I have my figure here, and I am given the angle FAC and angle CAE are supplementary angles. So I was told that, plus I could gather that because it's a linear pair. And I have to prove that x equals 40. So again, when I set up this proof, here's my two columns, statements, reasons. The first thing I start with is always the given. So I'm writing down that given information, exactly how it's worded, and the reason I'm allowed to say that angle FAC and angle CAE are supplementary angles is because it was given. Now I have to think, well, what does that actually mean? Well, what that actually means is that the measure of angle FAC plus the measure of angle CAE equals 180 degrees. I can say that because that is the definition of supplementary angles. So again, what's going here is the reason why I'm allowed to say what I just said to the left. So it's all about looking, okay, well, I've said something, what can I say next? Well, since I had this statement here, these two angles added together to equal 180 degrees, I can now say that 3x plus 20 plus x equals 180, and the reason why is substitution. I knew the angle FAC was marked as 3x plus 20, so I could substitute that in. And angle CAE, which is right here, was marked as x, so I could substitute that in. From here, I'm just doing algebra. My next statement, where I would go from here, would be 4x plus 20 equals 180. And the reason why I am saying 4x plus 20 equals 180 is because I've combined like terms. I just took my 3x and my x and combined them. The next thing I would do is I would have here 4x equals 160. And how I got that is I actually subtracted 20 from both sides. So the reason I can say that 4x equals 160 is because of the subtraction property of equality. I know it's kind of a lot of, to have to write down, but it is kind of important to actually say subtraction property of equality because it's not just subtraction. I just didn't say 5 minus 3 equals 2. I actually took a number and subtracted it from both sides of the equal sign, and that makes it that property of equality. And then from 4x equals 160, I would get x equals 40. And the reason I would have that is because of the division property of equality. Again, it's not written down because proofs, they're supposed to stay kind of neat and clean. If you need to do the work off to the side, that's fine. But you don't want to have a lot of scratch work here within the proof because the proof isn't really math, it's kind of logic, so it's a little different. You want to keep it all cleaned up. But I would have gotten this from dividing both sides by 4. So that is one proof when I was given supplementary angles. Okay. The next one is, I have a figure, it's a segment, and my given information is I'm given that the length of GM equals 42. Okay, I was also given some labels on here. I'm going to get to that later. But my starting information is the idea that this whole thing is 42. So again, the first statement I write down is that given. The length of GM equals 42. And the reason why is because it's given. This is where I have to think. Can't really jump too far forward. Remember, I said proofs are really, really nitpicky. You have to say everything, even if it seems very obvious. The only thing I know, given the fact that the length of GM equals 42, is that GU plus UM equals GM. That's the geometry there. And the reason I can say that is because of the segment addition postulate. A lot of people want to go straight to the geometry and say that 3 times g plus 4 plus 3g equals 42 because of the segment addition postulate. Again, going back to the idea of the nitpickiness, if I looked up the segment addition postulate, the dictionary wouldn't have 3 times g plus 4 plus 3g equals 42. It would have the idea that a little segment plus a little segment equals the whole entire segment. So that's why I had to start with the geometry. Once I've set up the geometric relationship that I know exists because of the segment addition postulate, then I can move into the algebra. I can now say that 3 times the quantity g plus 4 plus 3g equals 42 because of substitution. And then I'm just kind of doing algebra after that. So my next line from here to here, 3g plus 12 plus 3g equals 42. I'm able to say this because of the distributive property. That's what I would have done to get from this line to that line. So now I'm trying to get from this line to this line. I have 6g plus 12 equals 42. Well, what did I actually do? What did I do to get from this line to this line? Or why can I say 6g plus 12 equals 42? Because I combine like terms. Then where did I go from here? Well, now I have 6g equals 30. Well, again, you can think about it one of two ways. What did I do to get from this line to this line? Or why am I allowed to say this? Well, I'm allowed to say this because of the subtraction property of equality. In order to get from step 5 to step 6, I would have subtracted 12 from both sides of the equal sign. And then how did I get from this line to this line? I divided both sides by 6. And that's the division property of equality. And again, that's my last statement because that is exactly what I was supposed to prove. So that was basically a proof using the segment addition postulate. The angle addition postulate would work very much the same. It's just you would have a figure that was angles instead of a segment, and you would still have little angle plus little angle equals big angle. So your whole proof would look pretty similar, except right here you would just have angles instead of segments. Okay, the next proof is another segment, but this time I was given different information. I was given that C is the midpoint of AB, and I'm supposed to prove that X equals 8.5. So again, I'm starting with the given information. C is the midpoint of segment AB, that was given. Sometimes this next step is always the trickiest because you really have to think, what would I be allowed to say from that given information? Well, if I am given that C is the midpoint, then all I really know is that segment AC is congruent to segment CB because of the definition of a midpoint. That's what a midpoint does. It creates two equal segments. Where I'm going to go from there, because again, I can see where I'm going. I can see that I need to set up an equation to be able to solve for X. So once I've stated the geometric relationship, I can move into the algebra. Well, I know that if segment AC is congruent to segment CB, maybe I'll even mark that as segments, then I know that really the length of AC equals the length of CB. And I know that because congruent segments have equal lengths. Again, very obvious and very nitpicky, but that's the nature of the proof. And then where am I going to go from there? Well, if I know that AC equals CB, then I know that 5x equals 3x plus 17 because of substitution. I just took how the pieces were labeled and substituted them into the relationship that I had already established. And then where do I go from there? Well, to get from this line to this line, 2x equals 17, I would have subtracted 3x from both sides. So that's why I can say 2x equals 17 because of the subtraction property of equality. And then where do I go from there? Well, I would have divided both sides by 2. So I end up with x equals 8.5 because of the division property of equality. The last proof is similar to that, but I have to go a couple steps further. So for my last proof, I'm given this figure, it's angles, and I'm given that ray WY bisects angle XWZ. So this right here is bisecting this big angle here. And I'm supposed to prove that angle XWY right here is 48 degrees. So I'm still going to start with my givens, that ray WY bisects angle XWZ, and that's given. Again, I wrote that exactly how they gave it to me. Now I have to think, what does that actually mean? Well, if this whole big angle here got bisected, then it means this angle, XWY, is congruent to this angle, YWZ, because of the definition of angle bisector. That's what a bisector does. It cuts a larger angle into two equal pieces. Again, my relationship. If I know that the angles are congruent, then I know that their measures are the same. So the measure of angle XWY equals the measure of YWZ, because that is the definition of congruent angles. Or you could say congruent angles have the same measure, either way. Once I've established this relationship, then I can take what I was given here as far as the labels go and substitute that in. So angle XWY is 8x, and that equals angle YWZ, which is 4x plus 24. And again, the reason I can say this is because of substitution. And now I'm just doing algebra again. My next line is 4x equals 24 because of the subtraction property of equality. I would have subtracted 4x from both sides. My next line is x equals 6 because of the division property of equality. Again, I would have divided both sides by 4 to get this x equals 6. But again, I was not supposed to prove that x equals 6. I'm supposed to prove that angle XWY is 48. Again, I can see how that's going to happen, but proofs are real nitpicky, so I actually have to say everything. I have to go back to the idea that angle XWY is 8x because they gave me that information. Now, because I already solved for x, I can substitute it in. Now I can say that angle XWY is 48, and I can say it for a few different reasons. I mean, I simplified just basic multiplication. Again, different than multiplication property of equality, basic math, whatever you want to call it, because I just did 8 times 6. So again, 4 different proofs, very nitpicky. People tend to be a little bit uncomfortable with them, but really once you set up the geometric relationship, it kind of goes a lot easier after that. You just have to absolutely remember that you cannot assume anything. You can only use what you're given and what you can conclude logically from the given information. If you have any questions, let us know, and I'll see you in section 2.6.